Here we have a SAT math problem. Okay, let's go to the question. An equilateral triangle is inscribed in a circle with a diameter of 16. Which of the following gives the area of the equilateral triangle? Okay, first let me draw a circle with an equilateral triangle inscribed in it. Here we have a circle and there is an equilateral triangle inscribed in it. Since this is an equilateral triangle, all the three sides are equal in length. Okay, let's assume A as the length of each side of this equilateral triangle. Then there is a formula to get area of the equilateral triangle, that is a square root of 3 over 4 times A square. Okay, now our aim is to get the length of one of the sides of this equilateral triangle. Then we can plug in that length over here for A to get the area of the equilateral triangle. Okay, now let me take the center of the circle as O and this vertex as A and this vertex of the triangle as B. Let me draw a radius to the circle over here, that is the radius OB. And also let me draw a perpendicular line from the center of the circle to the side AB of this equilateral triangle. Okay, since this is a perpendicular line drawn from the center to the side AB, we'll have a right angle over here. And let's take the point C over here. Since this is an equilateral triangle, the measure of each interior angle is 60 degrees. So here we have 60 degree angle measure. Here we have 60 degree angle measure. Here also we have a 60 degree angle measure. And the radius OB over here will bisect this angle. That is, will divide this 60 degree angle measure into two equal parts. That is, the measure of this part is 30 degrees and the measure of this part is 30 degrees. And also the perpendicular line I have drawn from the center to the side AB, that is this OC will bisect the length of the side AB into two equal parts. That is, whatever length we have for CB, the same length we have for AC. Usually this will happen, that is this angle measure has been bisected by the radius and also the perpendicular line has bisected the length of AB into two equal parts only when we inscribe an equilateral triangle inside the triangle. Okay, now let's consider the right triangle OCB over here. And we know that this is a right angle, that is 90 degrees, and the measure of this interior angle is 30 degrees. Then what is the measure of this interior angle? It has to be 60 degrees, because in any triangle, the three interior angles must add up to 180 degrees. So this one is 90, this one is 30, 90 positive 30, 120. When I take 60 over here, we get the sum 180 degrees. And we have the diameter of the circle, that is 16. Then what is the radius of the circle? The radius of the circle is 8. We know that OB is the radius of the circle, so the length of this OB is 8. Okay, here we have a special right triangle, that is 30, 60, 90 special right triangle. In this special right triangle, OB is the hypotenuse because it is opposite to the right angle. Okay, whenever we have 30, 60, 90 special right triangle, the side of the triangle which is opposite to the smallest interior angle has to be considered as a shortest leg. Here OC is the side which is opposite to the smallest interior angle, 30 degrees. Then OC is the shortest leg of this triangle. Always we assume X as the length of the shortest leg of 30, 60, 90 triangle. Then the next longer leg is the side which is opposite to the interior angle 60 degrees. Now to get the length of this leg which is opposite to the interior angle 60 degrees, we have to multiply the length of the shortest leg X by square root of 3. Then the length of this CB is X times square root of 3. Now to get the length of the hypotenuse, we have to multiply the length of the shortest leg X by 2. Then we get 2X. So this 2X is the length of the hypotenuse. But already we know the length of the hypotenuse, that is the radius of the circle, 8. So this 2x and 8, both of them represent the same stuff, that is the length of the line segment OB. So we can equate them. That is 2x equals to 8. Now let's solve for x in this equation. Divide both sides by 2. Then this 2 will cancel out. We get x equals to 4. Okay, here I got the value of x, that is 4. In this one, let's replace this x by 4. Okay, now let me erase this, and instead of x times square root of 3, we can write 4 times square root of 3. Okay, already we have discussed the perpendicular line OC over here will bisect the side AB into two equal parts. That is the length of this CB, the length of this AC are equal. We got the length of CB, that is 4 times square root of 3. Then the length of AC is also 4 times square root of 3. Okay, then what is the length of AB? So we have to add this one and this one. Then we get 8 times square root of 3. So that is the length of each side of this equilateral triangle is 8 times square root of 3. Okay, now let's get the area of the equilateral triangle. We know that the formula is square root of 3 over 4 times a square. Okay, here square root of 3 over 4 times, here this lowercase here represents the length of each side of the equilateral triangle. So here the value of a is 8 times square root of 3. Let me plug in this 8 times square root of 3 for a over here. Then we get 8 times square root of 3 the whole square. Then we get square root of 3 over 4 times, since we have exponent 2 over here, we can write this stuff 2 times. Then we get 8 times square root of 3 times 8 times square root of 3. 4 goes into 4 one times and 4 goes into 8 two times. Here 2 times 8 is 16. Then we have square root of 3 times square root of 3 times square root of 3. 16. When I multiply square root of 3 and square root of 3, it is 3. Still we have 1 square root of 3. 16 times 3 is 48. That is 48 times square root of 3. Here I got the area of the equilateral triangle, that is 48 times square root of 3. We find this value in answer choice D. The correct answer choice for this question is D.